All right, team. So we did some if-then statements yesterday, which seemed to you probably like it had nothing to do with geometry. Although we talked a little bit about how there was some logic involved in those if-then statements. We learned what a conditional was, what a converse was. Now we're getting back into some actual visual geometry, and we are on section 3.2, and I have some words that you have probably heard of before and some definitions here. So we have parallel lines. There's a symbol for it. It's two lines that actually look parallel. Here's the example. And did you know that they mark parallel lines with these arrows to let you know that they will never, ever, ever touch, even though they continue in both directions forever? These symbols right here mean that they are parallel. So watch out for those like arrow looking things. Okay, they are lines that are on the same plane. And they do not intersect. So I have a couple like real life examples for you to think of also. Railroad tracks, the stripes in a road that keep you in the different lane, in the same lane, whatever. Those lines are all parallel because they never ever touch even if you extend them forever. We also have a vocab word called perpendicular, and this is the symbol for it. It's an upside down T. An example is we have a bunch of parallel or perpendicular lines in the corners of our room. I like to use our classroom as a way to, demonstrate and illustrate parallel lines, perpendicular lines, also skew lines, which we'll get to in a second. Makes me think of the timeout symbol. Those are perpendicular. They intersect at a 90-degree angle, so right angles. Make sure you've got that. 90-degree angles. And you will see a box in one of those four angles, which indicate that those lines are perpendicular. Now let's think about this for a second, because if angle 1 is 90 degrees because the box is there, don't we also know that angle 3 is also 90 degrees because what are these called again? Vertical angles. If this is 90, we know this one. Do you remember that from last chapter? You guys did a really good job on that test, so that one is 90. Let's see if we can take this a little bit farther, though. Let me figure out, let's highlight one of these lines. Doesn't matter which one, I'll look at this one. You know that lines have 180 degrees in them, right? And if this is 90 degrees, can you do some mental math to figure out what this one is? If they add up to 180, and if this side is 90, then I hope you recognize that this side is also 90. And by side, I mean angle. And now look, if we know this angle, we also know this one because of the bow ties, which is also 90 degrees. So why didn't they put a box in all four of them? The reason is because if one of them has a box, which means it's 90 degrees, that means that all four of these are 90 degrees, okay? That, my friends, is an example of perpendicular. And then we have one more vocab word called skew. That is when two lines go in different directions and they're on different planes. So kind of think about the walls in our classroom, how I've used those walls as examples before. What you need to keep in mind is that if you're going to have skew lines, they need to be on different planes or walls and also going in different directions, okay? Here is one example of skew lines. AD and HG. If you can picture this kind of a 3D image, this could be maybe the front top of the classroom, like above the whiteboard, and this would be in the back corner going up and down. Those lines, if you continue them forever, they will never, ever, ever touch because this one is in the front of the room on one plane and this one is in the back going a different direction on different planes. Okay, so that is one example. Let me try and give you a couple more. What about this line back here? FG and maybe AB. There's an example of skew lines. They are on different planes, aka different walls in the classroom, and also they go different directions. Here's an example of skew lines that sometimes confuse people. AE and CG. Those are not skew lines. Those are actually parallel, and I'll show you why. You can make a plane out of it. If you imagine a giant piece of paper that goes from one corner of the room to the other corner of the room, just like this is shown, these are technically not going in different directions. They're going in the same direction, which means they are not skew. So be careful about that. So one example of skew lines, how about this one and this one? Those are different planes, different directions. Let's do a couple example problems just to see. And we'll use our symbol. Remember, parallel means this and perpendicular means this. So you don't have to write the word. You can just use the symbol if you want to. line A and line E. So here's A and E, and it looks like they touch right here, which is a right angle, which means they are perpendicular. Line A and line B. Here's A, here's B. Can you see that those look like railroad tracks? Those are parallel. How about E and F? E and F, those look like railroad tracks. Those are parallel also. And F and A, let's see those. F, A, those intersect right here at a right angle. Those are perpendicular. Okay, let's try a couple more. Here's like our classroom 3D image. And I'm going to try and use my highlighters here so that we can kind of see what each question's talking about. DC and BC. Here's DC and here's BC. Looks like they intersect right here at a corner, and I know that corners are 90-degree angles in our classroom, so I'm going to put perpendicular for that. AE and DC. Here's AE, here's DC. Those are different planes, different directions. I believe those are skew. Remember, we don't have a symbol for skew like we do for parallel and perpendicular. So I'm just writing the word skew. AE and DH, let me erase this. Here's AE, here's DH. Do you see how those are parallel? They're going same direction, same plane. I'm going to use my symbol for parallel. A couple left, AD and DC. Here's AD, here's DC. Hint, if they share a letter, see how they both have D in them? That means that they're probably going to be perpendicular because they meet in a corner of a room, which is a right angle. DH and FG, let's figure out where those are. Here's DH, here's FG. I believe those are on different planes and they're going different directions. So FG is on this back wall right here and DH is on this side wall right here. So those are actually different planes going different directions. One's going this direction, one's going this direction. So those are skew. And I bet by process of elimination, you can predict what the last one's going to be. BF, which is here, and CG, which is here. Those, my friends, imagine like the tape, the black tape in the corner of the classroom. Those are parallel. Thanks for watching. Let's do some practice in class. Love you guys.